Hello, my name is Abigail Paul, and the title of my project is Recommendations for a New Water Treatment Facility Based on Water Production Data. So a little bit of background. In West Virginia, there are almost 4,000 producing unconventional wells, and a byproduct of these wells is produced water. Produced water comes from underground formations, and it's brought to the surface during the production of oil and gas. And this water typically contains high amounts of total dissolved solids such as chlorides, organics, and a bunch of other stuff that makes it very difficult to treat. Because of this, most of the produced water that's generated is stored underground through injection wells. And in West Virginia, most of the water that's generated here is stored in Ohio. This results in high transportation costs, and the water is typically transported in trucks similar to the one shown in Figure 1. The goal of my project was to first determine the amount of produced water that would need to be treated each year, then find feasible locations for a water treatment facility and determine the equipment that would be needed at such a facility, and then finally estimate the current cost of transporting the water for disposal and then compare that to the new cost of transporting the water to a new location. So the methods used in my project was first I compiled water production data for the years 2016 to 2019 and the locations of each well that had water production data, and a flow density map was then generated, and this is shown in Figure 2A. Based off of the density of the water, produced water, the three most dense locations were then picked, and the centermost location within those three regions is denoted with a star. And Figure 2B also shows the exact locations of the three centermost locations. For the costing of the transportation, I based it off of location 1 because location 1 had the highest density or highest amount of water. So I basically chose that to reflect the highest costs. Through literature reviews, the types of equipment that would be needed for a water treatment facility were determined, and the estimated cost of transportation to either treat the water or dispose of it were estimated using the following characteristics. So I assumed the capacity of a water tanker truck was 9,000 gallons. The distance to the injection well was approximately 58 miles, with it being 57.7 miles, plus or minus 25 miles to account for differences in distance. The average distance to location 1 was 12.5 miles, and the average cost of transportation per mile was $1.82. So moving on to my results, I found that the average cost of transporting the produced water to Ohio was about $6.5 million per year, and that's shown by the blue bar in Figure 3. The orange bar represents the cost of transporting the water to a proposed water treatment location at location 1, and that was just under $2 million. The average amount of water that a water treatment facility in location 1 would have to treat is about a little more than 1,100 gallons per minute. And in Figure 4, the schematic for a water treatment facility is shown. So the equipment that's needed and kind of like the process for it is shown in Figure 4. So the first piece of equipment that would be needed is an oil water separator, then an anaerobic and aeration basin, a clarifier, some form of filtration, either nano or ultrafiltration, a reactor, desalination, either through reverse osmosis, thermal distillation, or newer technologies, and finally ion exchange. So in conclusion, based on my results, there would be a decreased cost of transportation if a water treatment facility was built. In the future, I would like to actually size all of the equipment and simulate the water treatment facility to get an accurate cost of how much such a facility would cost to implement, and include that with the costing of transportation. Thank you.